Identifying functions. Common Core State Standard 8.f.a.1. A function is a rule that assigns one and only one unique output value for each input value. They are often depicted using a diagram like the one below. Input is brought into the function rule and then processed to create an output. Let's take a look at an example. Here our rule is multiply by 5. We take the input to the function, multiply it by 5 in order to get the output. Tables are a great way to represent how functions work. The x represents the input, the y represents the output. So if the input were 1, we'd multiply that by 5 and we would get 5. If the input were 2 and we multiplied that by 5, we would get 10. If the input were 4 and we multiplied that by 5, we would get 20. And finally, if the input were 6 and we multiplied that by 5, we would get 30. Each output of a function is dependent upon the input. Another way to say that is the output is a function of the input. Let's take a look at how that works. John is 5.5 feet tall. In order to calculate John's height in inches, we would use the following rule. The function rule would be we would take the input in feet, we would multiply it by 12 because there are 12 inches in every foot, and then we would get the output in inches. So we input 5.5, multiply it by 12, and we get 66. John's height in inches is dependent on his height in feet. Another way to say that is John's height in inches is a function of his height in feet. The output of a function is the function of the input. So in our example, John's height in inches is a function of his height in feet. This makes the input the independent variable, which would be graphed on the x-axis, and the output the dependent variable, which would be graphed on the y-axis. Let's do a quick check for understanding as we wrap things up. Which of these tables below represents a function? Another way we could ask the question is which one of these tables could be identified as having data of a function? Table 1 does represent a function. It has 2 3s for input, so it has the same input, but each of those inputs also has the same output. Therefore, we have one unique output for each input. And we could write a function rule to represent the data. In this case, the rule would be multiplied by 2. Table 2 does not represent or could be identified as being synonymous with a function. It does have 2 3s again in the input, but this time the outputs are different. The first 3 represented has a 12 for its output, and the second 3 has a 13. We could not write a function rule to represent this data. The third table represents a function. The data could be identified as belonging to a function, and the rule could be written here that we take the input, multiply it by 3 to get the output. We have one unique output for each input. Let's do a final quick check for understanding. For the tables below, can you determine the rule and use it to calculate the missing values in each table? You might want to press pause on the video here so you'll have time to analyze the data, figure out the rule, and then calculate the missing values. All right, all set? Let's go. For table 1, the rule is multiply by 2. The missing output for the input of 3 times 2 is 6. The missing output for the input of 5 is 10, because 5 times 2 is equal to 10. For table 2, the rule is add 3. So for the input value of 1, the missing output value would be 4. The trick here is we didn't have an input value for the 4th x value, but we did have an output value of 10. So we need to ask ourselves, what number could I add 3 to in order to arrive at the output of 10? Therefore, our input needed to be 7. The third and final table is pretty tricky. It actually requires 2 math operations. The rule would be multiply the input by 2 and then subtract 5. So for the input of 5, multiplying it by 2 would give us 10. Subtracting 5 would give us a final output of 5. For an input of 17, we would multiply that by 2 and then subtract 5. 17 times 2 is 34. Minus 5 gives us the final output value of 29. Because a function assigns one and only one unique output value for each input value, when a function is represented on the graph, it should never have the same x value with different y values. This can be determined by what is called the straight line test. Imagine a vertical line being drawn from top to bottom and then moved across the graph. It should never touch 2 points at the same time. This is what a vertical line test would look like. As you can see, the graph above represents a function because when the line is moved across the graph, it never touches 2 points at the same time. This graph, on the other hand, does not represent a function because it fails the straight line test. When the straight line moves across the graph, it touches 2 points at the same time, as you can see. Do either of the graphs depicted above represent a function? What do you think? In your mind, draw your vertical line and drag it across each graph. Do you hit more than 1 point at a time? For the one on the left, the answer is no, and therefore it represents a function. For the one on the right, the answer is yes. There are 2 instances where the line hits 2 points at the same time. G and F have the x value of 9. They both have different y values, one being 8, the other being 4. There's a second instance as well. At the x value of 14, J and K are both there, both with different y values. J has a value of 7, and K has a value of 2. When we look at a graph, we can tell if it represents a function as long as 2 points do not share the same x value with a different y value, or it passes the straight line test. Thanks for joining us to learn how to identify functions.